Okay, we are covering multiplying polynomials today, and then so this is the 19th, on Tuesday the 23rd will be your first Unit 1 test. We are looking at page 11, Multiply Polynomials. I'm going to teach this to you, and then we're going to finish the triples activity, page 12. Okay. You should already know how to multiply polynomials. You learned it last year. It is another one of those very important lessons that gets repeated throughout every math class beyond. Okay? So when am I ever going to use this? You're going to use this in every math class from here on out. No, you're not going to be 42 years old walking down the street and told multiply some polynomials. But yes, you will have to know this in any future math classes. Okay, so the first thing you need to know is that when we're multiplying polynomials, we use what's called the distributive property. Last year, you may have been taught the distributive property using the box method. Sound familiar?
Yes.
Okay, the box method works. However, when you get to higher up math classes, you should graduate from the box method to what's called the distributive property method, which is what I'm going to show you today. Okay? If you do not like my method, then go back to the box method. But you're not going to see me use the box method. Y'all with me? All right, here we go. Here's the instruction. Stay with me. You're going to multiply every term in the first set of parentheses by every term in the second set. Don't forget that when you multiply variables where you can see the bases, you end up just adding the exponents together. You don't multiply the exponents. Then you combine like terms, then you write in standard form. So, let's look at the first example. Here's our example right here. I'm going to show you, I call it the beat, repeat method. Beat, repeat. Here's why I call it that. Now watch. See the first set of parentheses? First of all, let me show you what I've seen people mess up on. Remember the IXL you just did? Didn't it have parentheses, polynomial, and then a parentheses polynomial? Yes? And then what was in between the parentheses? A plus or a minus. This looks very similar, but in between the parentheses there is nothing. This is when you multiply. I've seen people with I'm going to make it very simple. With an addition problem in front of them, I've seen people multiply. They just see parentheses and parentheses. They completely ignore that what is this? That just means add. So be careful. Pay attention to what's in between the parentheses. If there's nothing like this, it means multiply. All right, here's how you do it. The first set of parentheses. How many terms are in here? 2. We're going to split them up. Watch how I do this. 3x beep, plus 2. Beep. You see that? Why do you think I wrote a beep? That is going to repeat in here. So what you've just done, if you will remember, now that's only the first example. I'll do another one to show you. But if you will remember how to set it up like that, you've now just turned it into a binomial times a binomial into one thing times a binomial. You just distribute. That's it. You already know how to do this. You took it from something you may not have known how to do to now you've written it in a manner that, oh, I'm just multiplying. You see that? So multiply. So 3x times x. 3x squared. 3x times negative 5.
Negative 15x.
2 times x. 2 times negative 5.
Negative 10.
And then in the middle, these will always be like terms that you can combine. If you have negative 15x plus 2x, that would be negative 13x. Bring the other stuff down. And that's the answer. I find it easier than the box method. It's more, I don't want to sound like the box method is not smart. The box method helps people organize their work. If you can organize your own work, that method is preferred because it's more academically inclined, which means you're going to see it in college. You will not see a college student using the box method because they have graduated from it, you know what I mean? They've gone into this. So it's good to go ahead and see this and start practicing it. And all it is that you're taking the first term times the whole thing, then you're taking the second term times the whole thing. So it's exactly what you're already doing in the box method. It's just now you're organizing it like a sophomore in high school. All right, so let's practice. Here we go. We're going to set it up, split repeat or beep repeat. So look at this, split it up. You got x beep minus 6 beep. Beeps really help. Caleb, write this down. And then now you're going to repeat what's in the parentheses, the second set. It goes in the beep. And now you distribute. So x times x minus 4 is x squared minus 4x, right? Negative 6 times x, negative 6 times negative 4, then don't forget to combine your terms in the middle. Keep writing, Caleb. Do you have a pencil? I want y'all to try number 2. So split the first set up. If it helps, draw the little slash to help you see what's split apart. I ain't helping you. Don't do that. So something unusual happens on this one that didn't happen on the other. What did you notice? What happened? There's no middle term. It went away. There's a reason why. get that?
Yep.
Okay, I need you to write some vocab words right here. This is called a difference of squares. Here's why it's called that. Come to... Is there any here? There's really not. Okay. Draw a vertical line if you can right here. And I want you to write another vocab word. And I want you to write that. Then I'm going to explain it. So write it, then I'll explain it. There's two types of vocab words in polynomials that you need to know. You're going to hear them a lot. And if you can memorize when you have, like, what they look like, if you can memorize it, it makes math so much easier. Okay? This is one of those good to know. You don't have to know it, but it's a good to know to make your life easier. Okay? Look at the one that says perfect square. This is called a perfect square, y'all with me? Because it's saying take this, 2x plus 3, and do what to it? Square it. That means, I'm not actually multiplying it out, that means you write it how many times?
Twice.
You write it twice. I'm really running out of room here, but I'm trying my best to write it twice. It means write it twice, right? Then you would multiply it out. Okay, look at the difference. Focus your attention here and here. What's the difference? There's only one difference. What is it? There's a sign difference, right? It's a negative right there. Right there. You can't even see it now because I did too much highlight. But there is a sign difference here. Hence the name difference of squares. This is a perfect square because it's it times itself. And then this is a difference of squares because there's one difference that's keeping it from being a perfect square, right? Okay, so in a difference of squares, the middle term always cancels, every time. In a perfect square, you will have the middle term. But in a difference of squares, it always disappears. Okay, now let's try these right here. Number 3. What is different here? That's a trinomial. Did you learn the FOIL method last year? No? Did someone say it? Okay, perfect. I'm glad you did. All right, anyways. You're still going to do this, my method. Split. Repeat. Now your repeat needs to be bigger here, right? Because it's going to have 3 terms going in it. So x beep minus a beep. You with me? And then I'm going to repeat that in here and here. And then once again, you are still just multiplying one thing into a set of parentheses. So it's just basic multiplication. You've taken a complicated binomial times a trinomial, and you've turned it into a monomial times a trinomial. So now it's doable. So x times 2x squared, 2x cubed, there you go. X times negative 3x, x times 5.
5x.
Notice as I'm doing this, I'm visualizing drawing the arches. You can draw them if you want to, or you can just trace your finger on your paper. Negative 8 times 2x squared. Good. Negative 8 times negative 3x. Good. Negative 8 times 5. Then you can look at it, and there is a lot going on here. So you could go to what we did yesterday, where we draw lines underneath based on the exponent, so you know what's combining, right? And you also can see what needs to be in the front. So what has to be in the front? 2x cubed, right, Harmony? 2x cubed goes in front. The squareds will combine. You got negative 3 minus 16. Good. Then the single. Good. And then bring that down. All right, you try 4. It's the same thing. They just made it into a word problem instead of the fancy written out like linear. You want to break apart the binomial, though. So I'm going to set it up. You look and see if you set it up right. I've got x squared plus 4x. Repeat the trinomial. Now you've created a monomial times a trinomial. You're just going to add the exponents, right? Y'all with me? Okay, don't look up here until you've completely tried it. Not going to serve you any good if you're just copying it down. this answer. If you did not get it, let me come look at it. All right. It might be a minor mistake. Right here, 4x times x cubed. So that's 1, so 4 right there. That was the one problem. Everything else is right. Okay, go to page 12. Number 5 on here we're going to save for another day, for Monday. Go to page 12. And at this point now, you should be able to do all 30 questions.
The reason I know my 6 is